Good day everyone. This is the part 2 of the arithmetic series tutorial. So let's dig in. So remember our formula S sub n is equal to n over 2 times the sum of a sub 1 plus the last term. So this is our arithmetic series formula wherein a sub 1 stands for the first term, n is the number of terms, and a sub n is the nth term or the last term. Before we use this formula on the previous example, the previous tutorial, we need first to solve for a sub n, which is the last term. And we keep using the formula a sub n equals to a sub 1 plus quantity n minus 1 multiplied by d. We always use this formula in order for us to find a sub n, and then using this formula again to find the sum of the first n terms. Now, what if we're going to substitute the formula for a sub n in the formula itself? So let's try to enumerate that. We have the formula for the arithmetic sequence a sub n equals to a sub 1 plus n minus 1 multiplied by d. Now, instead of writing a sub n on the arithmetic series formula, why not let's just write this and try to solve a problem in one glance. So therefore, if we're going to do that, we're going to have S sub n is equal to n over 2 multiply a sub 1 plus, again, instead of a sub n, instead of this, we'll just put this a sub 1 plus quantity n minus 1 multiply by d. Now we have a combined formula for the arithmetic series and arithmetic sequence. Now let's try to simplify it. Let's simplify it by combining like terms, which is a sub 1. So we have S sub n is equal to n over 2 multiplied by 2 a sub 1 plus n minus 1 quantity multiplied d. So this is now our new formula for the arithmetic sequence, for the arithmetic series. Now, since we have a new formula, so we can now find the sum of the first n term if we have the following given. First is a sub 1, n, and the common difference. So all these three variables are what we need in order for us to find the sum for the first n term of the arithmetic series. Now let's compare the following example. What is the sum of the arithmetic series 3 plus 7 plus 11 and so forth until a sub 15? So we just try to use the old thing that we're going to do that we always doing. So write the given. See here, we just need to solve first for a sub n, which is a sub 15. And then after solving a sub 15, we're going to try to use another formula to solve for the sum of the first 15 terms. Now let's try using our new formula. All we need to do is to find the following given: a sub 1, n, or the number of terms, and the common difference. Now using the formula, just copy it and substitute all the values that we have. That is 15 for n, um, 3 for a sub 1, 15 for n again, and 4 for the common difference. So having that, let's just simplify first all the things that inside the groupings or the parentheses. So let's have 6 plus 14 times 4. 14 times 4 is 56. Then let's add that. And it's easy for us now to solve for the sum of the first 15 terms. So, so if I were to ask you if what formula you're going to do or to use, it's up to you on how to use it, on which one to use. A question. Find the sum of the first 30 terms of the arithmetic sequence negative 12, negative 16, and negative 20. In this case, I will be using the formula, the combined formula that we use. Where we have a sub 1 as negative 12, and n is the n is 30. For we are asked to find the sum of the first 30 terms. So the common difference is negative 4. So we have the formula, then substitute all the value, simplify, and add, and then we get the final answer, which is negative 2,100. Example number 9. Find the sum of the arithmetic series 2 plus 5 plus 8 plus so on up to 89. In this case, we don't know the number of terms of the sequence. You could just add all of them and try to do it manually, but it would take you ages. For this example, we will use the old formula for arithmetic sequence to solve for the value of n. With the following given, a sub 1 is 2, the common difference is 3, and the last term a sub n is 89. So let's solve for n. Let's just substitute all the values that we have. Then combine like terms, then add 1 on both sides, then divide 3 on both sides. So we can get the value of 30 for our n. So we just prove that the sequence has a 30 terms sequence. So now we have the value of n and we have the last term. We can now solve for the sum of the first of the series. And the sum is 1365. See, it is different from the other example because a sub 1 and a sub n is given and we don't know the value of n. That's why we solve for the value of n because it's also essential for us to know the answer in this question. Now, example number 10. Find the sum of all even integers between 21 and 75. The word between indicates or tells us that 21 and 75 doesn't include in the sequence. Now, let's ask ourselves what is the next number, that next even number after 21? And that is 22. And this will become our a sub 1. Now, ask yourself again, what is the highest even number before 75? And that is 74. And this will be our a sub n. Now, we have our first term and we have our last term, but we don't know how many terms are there in this sequence. So all we need to do is to do the things that we do on example number 9. Let's first solve for the value of n. So using the arithmetic sequence formula, just add all the values, just substitute all the values that we have, combine like terms, and subtract 20 on both sides. Then divide both sides by 2, and we get the value of n is as 27. So there are 27 terms in this sequence. Now, knowing the first term and the last term and the number of terms, we can now solve for the sum of the first 27 terms, or the sum of all even integers between 21 and 75. And that is S sub 27 is equal to 1,296. So that's all for the part 2. Hope that you learned something from this discussion and hope that you stay tuned for my next tutorial about geometrics. That's all for today and bye. Thank you.